Okay, so let's do the second method I promised to show now. I have written the equation from where we have. So like I told you in the first video, whether you're using any method you're using, we will always start our partial fractions like this, get to this equation step, and start using the method that we want to use. And that's what we did in the first part of the video when we used a particular method to solve for A and B. So now in this method we're having a different setup, but we are going to use the same exact equation. So this is what we have here. So what does this equation really involve? In this method we are trying to get a little bit of a simultaneous equation from there, because we have an equation in A, we have another equation in B, and something like that. Then we try to solve. So let's see how that one works. So what happened is that we are going to expand this bracket. We're going to multiply it and see what we have. So we have 7x minus 1 equals to, when you expand, we have 2ax plus 3a plus 3bx minus b. Okay, so let us put our equation together now. 7x minus 1 equals to, put the terms that have x together and the term that does not have x together. So that's going to be 2ax plus 3bx plus, what do we have here, 3a minus b. So we have 7x minus 1 equals to, what do we have here, we have 2a plus 3b. Those ones have x, so we factorize by x, and yeah, these ones do not have anything, so let's just put them together, 3a minus b as well. So now we've brought them all together like that. So what does this mean? Now, by comparing the coefficients of your equation, because this is the equation we have, it means that when we had our 2a and 3b together, we must arrive at this 7 here. And that when we add 3a minus b, we must arrive at this minus 1 that is here. So just with the idea that we just did, we are going to drag out our equation from there. And that's what we call comparing coefficients. Comparing coefficients. So let's see what we have. When we say 2a plus 3b, we had 2a plus 3b. It must be equal to what? This 7 that is here. So in this case, we compare the coefficients of x that we have. So we have 2a plus 3b must give us 7. And here, this one is for constant term. I represent my constant with a c, meaning that it doesn't have any x or any variable. It's just an ordinary number. So here it says 3a minus b. 3a minus b is equals to, here this is minus 1. So I'll call this equation 2 and call this equation 3. Now the reason why I called it equation 2 and 3 is because this was originally my equation 1. I don't want to call the same names over and over again. So what do? I have a simultaneous equation here. So but because I have taught simultaneous equation, we've solved simultaneous equation many times, I don't need to show you the steps of solving a simultaneous equation here. I'll just get the answers from my calculator like that. So once I plug it into my calculator, so this is how you do it with a calculator. You press the mode, you press 5 for equation, and you press 1 for this mode. So you see, it will ask you to write the coefficients of your simultaneous equation. In this case, we have 2. In the other one, we have 3. And the third one, we have 7. So here we have 3. Here we have minus 1. And the answer we got minus 1. And the answer we have is minus 1. Sorry. Minus 1. So by the time it's solved, it told me that a is equals to 4 over 11. And that b is going to be equal to 23 over 11 as well, which is exactly what we got here, right? So using this method, we're able to drag out our simultaneous equation from there, and we are able to solve. So the advantage of this second method is that it is useful for every method of or different types of partial fractions that we have. Any type of it that we have, it will always solve. But this initial method now, it only works for when we have a linear case. In the case of, let's say, our denominator says something like this. So let's say it says something like, let me locate a free space. Let's say we have a over x squared minus, let's say, 6 or something like that. Now it couldn't work because normally you're expecting to take x squared minus 6 equals to 0. If you take 6, x squared equals to 6. We can't do something like that. Yeah, we only work for it when we have a linear case like your x minus 6, in which you take x minus 6 equals to 0 and x is equals to 6. So anytime we have a quadratic stuff in the denominator, we don't even use it at all. It's better to stick with our method. So as we see, it's not exact, it's not that hard. It's actually quite very easy as well. So, and because in our partial fractions, you'll be seeing your x squared in the denominator many times. And as we can see it, we saw it here, you see it here, it's even here in a way, and then it's also here as well. Okay, well, it's not here, but it could be, right? So any case like that, we just stick to the second method that I just explained. And yes, for my own work, when you are going to do it, I am actually going to really demand that I see the solution step of your simultaneous equation. So yeah, that's what I'm going to do. You are going to show the steps. You solve this and then you got that. So that's how that one works. So that's that about that. We've solved for equation 1. We solved question 1 and question 2 now. Solve question 2 using the two methods that we show you. So there's going to be an additional third equation now, and this third equation, the third question, I'm going to just use this method, this second method that I just taught. And that's it. I hope you really understand what we are doing here, and we'll catch up in the next one.